So as you can see, that table is the question. Now I want to solve this under SPT, shortest processing time. That is the meaning, and those are the formulas there. So that is the question there. So they will tell you to find those 6 things. That is the optimal sequence, completion time, whatever. So first, I'm trying to illustrate using the table. I put back the table, and then you look at the list in each of them, like the list time. Use it to determine the job. The list, it should be in time. Wherever the time becomes the same thing, like for job C and job G, the time is both 8 and 8. Then you look at the due date, but you arrange from the smallest to the biggest. That's what you are doing, from the smallest to the biggest, which we have 4, which is in job D, 5, which is in job A. Then we have C and G, obviously the same 8, 8. So what do? We check the other side. I'll see that C comes before G because 12 comes before 45. Then 10, 15, 20 as BEF. That is the optimal sequence. Now that I have seen it, we arrange it as 1, 2, 3, 4, 5, 6, 7. The second one is the completion of time of jobs, right? Completion time of job. Each are adding each other. The first one is 4, second one is 5. So 4 plus 5, 9. The third one is 8. So 9 plus 8, 17. Fourth one is, you get the idea, 8. 9, 17 plus 8, 25. Fifth one, 10. 25 plus 10, 35. Sixth one is 15. 35 plus 15, 15. Seventh one is, you get the idea, 20, which is 50 plus 20, 70. Then let's look at the mean flow time, meaning all of those completion, this thing you have, divided by how many they are, and those numbers are 7. So when you add those completion time, you get 110. Divided by that 7 is 30 minutes. Remember, they say flow time, so it's in minutes. Now remember when we do the other optimal sequence, when we arrange in 1 to 7, we're going to reverse it and arrange it in descending order, which is 7, 6, 5, 4, 3, 2, 1. That's why you see it under those jobs, which is D, A, C, G, B, F. Then the up, remember the normal numbers we have in, which means they are corresponding numbers in the due date. What D is, you put it there is 4. What A is, you see is 8. Put it in due date, not in time, not due date, or in time. Then when we do that, obviously you start multiplying those numbers up and down. 7 times 4, 6 times 5. So you have first have to find those two things, like I said. The first one in descending order, 7 to 1. The second one in their due date. When they are times in there, they add each other, divided by the 70, because times so you divide by 70 because you actually divide by the addition of the due date, which you see 4 plus 5 plus 8 plus 8 plus 15 plus 10 plus 20. You get that 70. That's how we got it. So if you divide those two, obviously we get 3 jobs. That is how we got it. Then fifth one, lateness, mean lateness and maximum. So lateness in a minute is got it from 10 divided by what? Their due minutes. The normal completion time, each by their due minutes. Not the due time, and not the time, the completion time. Remember, 4, 9, you get the idea. So each by the distance. So when we're minusing, you get 4 minus 25, 9 minus 15. If you are checking it in the table for the due date, you'll see all those 25, 15, 40. Then if you are checking the jobs and the completion time, you see 4, 9, 17. So you minus it, whatever you get, bring it. Anyone with minus means the job was done early, because you are doing a job, supposed to reduce, so minus should be there. But anyone without that minus means it's a job late. So after I find that lateness, the mean, you find the mean of it. That's what I mean by mean lateness, which means you add all of those lateness you have and you divide by 7. It's the same number up that will just scroll down again. You see that we got 28. When you do minus 21, minus 6, minus plus 2, like that, there are 4 jobs later. If you look at it, we'll get 28. That plus minus, if you times it, you see that it's minus. So that's why I did not say plus minus here. So if we do all the other time, we'll divide 28 by 7. We'll get 4 minutes. And then look at the 7th one, number of jobs actually late. Easy. Find any number without the minus, count how many, and put it. Those are the number of jobs late. Anyway, that's under the SPT. Most things not change, but under WSPT, weighted shortest processing time, that is meaning you add WI in the question, which is what it was in your past question. So if you add it, you have to times due date with weighted processing time to get, by weighted time to get important weight, to get weighted due date, the new one. You multiply them like that, 15 times 1, 12 times 2. You are seeing them in both due date and important weight column. That's how we get those figures that were calculated. And then we'll call the table weighted due date. We just join So there are some things that you need to do with due date. You have to use weighted due date instead. But when weighted have entered, it means you are now adding more addition. Remember all this cost accounting, they have all this weighted average method to get stock. Now, first one will not be affected, optimum sequence, because nothing really need due date there. Second one will not be affected. No, it's the same question. Mean flow time, it's, the same division by 7, all of them are 7. Third one, sorry, that was even the third one. Second one, completion of time, the same thing, they don't need due date. Now, in that third question, they also ask for weighted time. So in that case, you now have to multiply, you can see them by the important weight, because they say weighted time is the weight system you're dealing with, not the due date. So you multiply each of those ones that you get in completion time this time, not just like the normal mean, you multiply them by what their respective important weight before you now divide by 7 and get that answer that we have there. And when you have got that, you get 67 minutes. Remember, they say mean flow in minutes, meaning in minutes that is time, mean time, sorry. So, and remember, this work have been in minutes. The fourth one, average in process inventory. You can see average process inventory will not really be affected also, since it's the same question, don't need due date. Now, if you remember, we needed due dates, for the last formula. So since now we said the new due date will be the weighted one. The fifth one, lateness in minutes, is completion time of each job minus their respective due date. Right now it's minus their respective weighted due date. It's still almost the same thing, but now you're looking at the weighted due date, the new column we just formed, and be comparing where they are in the horizontal arrangement, and you'll get all of this if you apply it the way we applied the last time. Mean lateness, those answers you get up like we did, the lateness divided by how many they are, which are still 7 numbers. If you do that, you would get, all those minus 21, minus 6, minus 28, minus 20, plus 11, minus 10, minus 50 divided by 7. You will get minus 124 divided by 7, which is minus 17.71. Now, there was something I forgot to say. That maximum lateness, we did it the last time. It was, remember, I said the lateness are the number of positive, like they don't have minus. So you check the biggest number that don't have minus in that one. That's how we got that 30. Or yes, 30, because it was the biggest. There was 2, there was 23, there was 20, there was 30 that time, right? Now, the only number that don't have it is 11. So it is the only one, because by default it's the biggest. There's no other one. It is the biggest. So it's the maximum lateness number. And then finally, number of jobs actually late. It's only 11 that don't have plus. I just said that, which means this time it's one job, because when you are adding instead of subtracting, it's one job. Job's supposed to be what? Reducing. I've explained that already. So good luck here, and bye.